The SR-469 Motor Management Relay is a microprocessor-based relay designed for the protection and management of medium and large horsepower motors and driven equipment. The thermal model incorporates unbalanced biasing, RTD feedback, and exponential cooling. In addition to the 15 standard overload curves and custom curves, the SR-469 has a curve specifically designed for the start of high inertia loads when the acceleration time exceeds the safe stall time. Motor protection, fault diagnostics, power metering, and RTU functions are integrated into one economical draw-out package. SR-469 installation. The 469 case can be installed in the panel of a standard 19-inch rack, either alone or adjacent to another SR series unit. Ensure that the front door of the relay is able to swing open without interfering with adjacent equipment. Normally, the 469 unit is mounted in its case when it is shipped from the factory. The 469 should be removed from its case before mounting the case in the supporting panel. To remove the unit from the case, first turn off control power before drawing out or reinserting the relay to prevent maloperation. To remove the unit from the case, open the cover by grasping the center of the right side, press upward on the latch, and then pull the front door, which will rotate about the hinges on the left. Release the locking latch, located below the locking handle, by pressing upward on the latch with the tip of a screwdriver. While holding the latch raised, grasp the locking handle in the center and pull firmly, rotating the handle up from the bottom of the unit until movement ceases. Rotate the handle to the stop position. Once the handle is released from the locking mechanism, the unit can freely slide out of the case when pulled by the handle. It may sometimes be necessary to adjust the handle position slightly to free the unit. Mounting instructions. Review the dimensions and location of the relay wiring before selecting a location within the panel that is appropriate for the relay. Cut the hole in the panel to the dimensions shown in the drawings. After the mounting hole in the panel has been prepared, slide the 469 case into the panel from the front. Apply firm pressure on the front to ensure the front bezel fits snugly against the front of the panel. Bend out the pair of retaining tabs to a horizontal position from each side of the case as shown. The case is now securely mounted, ready for panel wiring. If additional support is desired, the optional SR mounting kit may be ordered. To insert the unit into the case. If an attempt is made to install a unit into a non-matching case, the mechanical key will prevent full insertion of the unit. Do not apply strong force in the following step or damage may result. Raise the locking handle to the highest position. Hold the unit in front of the case and align the rolling guide pins near the hinges of the locking handle to the guide slots on either side of the case. Slide the unit into the case until the guide pins on the unit have engaged the guide slots on either side of the case. Grasp the locking handle from the center and press down firmly, rotating the handle from the raised position toward the bottom of the unit. When the unit is fully inserted, the latch will be heard to click, locking the handle in the final position. Status indicators for the 469, motor and output relay status, in addition to a 40-character message display and keypad, allow control, programming, and status monitoring without the need for a computer. However, the conveniently located front RS-232 port allows easy connection to a computer for programming and monitoring. The SR-469's draw-out handle has provision for a wire-led seal to detect unauthorized removal. The SR-469 is packaged in the standard multi-lin SR series configuration of a draw-out unit and a companion fixed case. The case provides both mechanical protection and is the termination for all connections to external equipment. Current transformer connections within the case are fitted with automatic CT shorting mechanisms. The unit is held in the case by pins on the locking handle, which cannot be fully lowered to the locked position until all electrical connections are fully mated. Any SR-469 can be installed in any SR-469 case, except for custom manufactured units, which are clearly identified as such on both case and unit. An index pin keying mechanism prevents incorrect pairing. SR-469 display. All messages are displayed on a 40-character vacuum fluorescent display to make them visible under poor lighting conditions. While the keypad and display are not being used, the display will default to user-defined status messages. Any trip, alarm, or start block will automatically override the default messages and appear on the display. Pressing the Help key for 2 seconds will initiate a lamp test. The SR-469 has 3 groups of LED indicators on the faceplate that indicate the status of the SR-469, motor, and output relays. The meaning of these indicators is as follows. First, let's look at the SR-469 status LED indicators. The SR-469 in-service LED indicates that control power is applied and all monitored input, output, and internal systems are okay. The SR-469 has been programmed, and the SR-469 is in protection mode, not simulation mode. When in simulation or testing mode, the LED indicator will flash. The Setpoint Access LED indicates that access jumper is installed and passcode protection has been satisfied. Set points may be altered and stored. The Computer RS-232 LED flashes when there is activity on the COM port and remains on solid if incoming data is valid. The Computer RS-485 LED flashes when there is activity on the COM port and remains on if incoming data is valid and intended for the slave address programmed in the relay. The auxiliary RS-485 LED flashes when there is activity on the COM port and remains on solid if incoming data is valid and intended for the slave address programmed in the relay. The lockout LED indicates that start attempts will be blocked either by a programmed lockout time or a condition that is still present. The Reset Possible LED indicates that a trip or latched alarm may be reset. Pressing the Reset key will clear the said trip or alarm. The Message LED flashes when a trip, alarm, or start block occurs. Pressing the next key will scroll through diagnostic messages. It will remain solid when setpoint and actual value messages are being viewed. Pressing the next key will return the display to the default messages. Motor Status LED Indicators. The Stopped LED indicates that the motor is stopped based on zero phase current and starter status auxiliary contact feedback. The Starting LED indicates that the motor is starting. The Running LED indicates that the motor is running normally below overload pickup level. The Overload LED indicates that the motor is running above overload pickup level. The Unbalance Pickup LED indicates that the level of current unbalance has exceeded the unbalance alarm or trip level. The Ground Pickup LED indicates that the level of ground current has exceeded the ground fault alarm or trip level. The Hot RTD LED indicates that one of the RTD measurements has exceeded its RTD alarm or trip level. The Loss of Load LED indicates that the average motor current has fallen below the undercurrent alarm or trip level, or that power consumption has fallen below the underpower alarm or trip level. Output Relay LED Indicators. The R1 Trip LED indicates that the R1 trip relay has operated or energized. The R2 Auxiliary LED indicates that the R2 auxiliary relay has operated or energized. The R3 Auxiliary LED indicates that the R3 auxiliary relay has operated or energized. The R4 Alarm LED indicates that the R4 alarm relay has operated or energized. The R5 Block Start LED indicates that the R5 Block Start relay has operated or energized. The R6 Service LED indicates that the R6 service relay has operated. The 469 keypad operation. The 469 messages are organized into pages under the headings Set Points and Actual Values. The Set Point key navigates through the Programmable Parameters page headers, while the Actual key navigates through the Measured Parameters page headers. Each page is broken down further into logical subgroups of messages. The Message Up and Message Down keys may be used to navigate through the subgroups. The Enter key is dual purpose. It is used to enter the subgroups or store altered set point values. The key Escape is also dual purpose. It may be used to exit the subgroups or to return an altered set point to its original value before it has been stored. The Value Up and Value Down keys scroll through variables in the set point programming mode and increment and decrement numerical set point values. Alternately, these values may be entered with the numeric keypad. The Help key may be pressed at any time to display context-sensitive help messages. Entering alphanumeric text.
To customize the 469 for specific applications, custom text messages may be programmed in several places. One example is the message scratch pad. To enter alphanumeric text messages, the following procedure should be followed. For example, to enter the text "Check fluid levels," press the decimal key to enter the text editing mode. Press the value up or value down keys until C appears, then press the decimal key to advance the cursor to the next position. Repeat step 2 for the remaining characters H, E, C, K, F, L, U, I, D, L, E, V, E, L, S. Press Enter to store the text message. Entering plus or minus signs. The 469 does not have plus or minus keys. Negative numbers may be entered in one of two manners. Immediately pressing the value up or value down keys causes the set point to scroll through its range, including any negative numbers. After entering at least one digit of a numeric set point value, pressing the value up or value down keys will change the sign of the value where applicable. The SR-469 front RS-232 port. This port is intended for connection to a portable PC. Set point files may be created at any location and downloaded through this port using the SR-469 setup program. Local interrogation of set points and actual values is also possible. New firmware may be downloaded to the SR-469 flash memory through this port. Upgrading of the relay firmware does not require a hardware EPROM change. There are two possible display configurations available with the SR-469 relay. They are the basic and enhanced displays. New production units will have the enhanced display, while older relays will have the basic display. The main differences between the basic and enhanced displays are the larger LCD display and the keypad interface for programming and viewing set points through the front panel. With the enhanced display, the relay's messages are still organized into pages under the main headings of set points and actual values, with the additional heading of target messages. The menu key is used to navigate through the main headings. Within each main heading, the message keys may be used to navigate through the subgroups. For example, when the menu key has been used to select the actual value main page, pressing the message right key will move you into the A1 status menu. The message up and message down buttons can then be used to view the headers for the other actual value submenus, such as A2 metering data and A3 learned data. To view the specific information in a subheading, use the message right key. For example, when in the A1 status subheading, press message right to see the heading for generator status. The message up and down keys can again be used to navigate the headings under the A1 status subheading. The Enter, Escape, Value, and Help key operations will remain the same as the basic display. The only other difference is when viewing messages. If the message LED is illuminated, indicating that there are messages waiting in the relay, the message down key can be used to view the messages. The main learning objective for this section is to understand the basic wiring concepts with respect to the 469. Digital inputs. There are 9 digital inputs that are designed for dry contact connection to other devices. 2 of the digital inputs, the access and test inputs, have their own common, while the rest of the inputs share a common. The positive side of the 24-volt DC switch supply is brought to a terminal to provide control power for inductive or capacitive proximity switches. The NPN output of the proximity switch can be connected to any of the 4 assignable digital inputs configured as a counter or tachometer. Ensure that the maximum current draw from the 24-volt DC switch supply isn't exceeded. 5 of the 9 digital inputs have been pre-assigned. One of the 5, the starter status input, may be configured for either a 52A or 52B auxiliary contact. The function of the remaining 4 digital inputs may be assigned during the configuration of a protection or control element. Some of the assignable functions are limited to a specific input. For example, if the 2-speed motor feature is enabled, assignable input 4 will be dedicated as the 2-speed motor monitor input, while other functions, if enabled, can be configured to any of the remaining unassigned inputs. Warning:
To avoid damaging the SR-469 inputs, do not connect an external power supply to the SR-469 input circuitry. Use only dry contact connections from external devices. Control power connection. The control power supply to the SR-469 must match the installed switching power supply. If the applied voltage does not match, damage to the unit may occur. The order code on the terminal label on the side of the drawout unit specifies the nominal control voltage as one of the following. For low voltage connection, the label will read low 20-60 VDC, 20-48 VAC. For high voltage connection, the label will read high 90-300 VDC, 70-265 VAC. Extensive filtering and transient protection are built into the SR-469 to ensure proper operation in harsh industrial environments. Transient energy must be conducted back to the source through the filter ground terminal. A separate safety ground terminal is provided for high pot testing. All grounds must be hooked up for normal operation regardless of control power supply type. The access switch. Terminals C1 and C2 must be shorted to allow any set point value to be changed. This safeguard is in addition to the set point passcode feature, which functions independently. The test switch. Once the SR-469 is in service, it may be tested from time to time as part of a regular maintenance schedule. The relay will have accumulated statistical information relating to starter and motor operation. When the relay is under test, shorting the SR-469 test input, C3 and C4, will prevent all of this data from being corrupted or updated. The SR-469 in-service LED or indicator will flash while the SR-469 test terminals are shorted. Emergency restart. Shorting terminals D17 and D23 will reset the thermal capacity used, starts per hour block lockout, and time between starts block lockout to 0, and reset all trips and alarms so that a hot motor may be restarted. However, the restart block lockout will remain active as it may be used as a backspin timer, and any trip condition that is still present, such as a hot RTD, will still cause a trip. Remote reset. Shorting terminals D18 and D23 will reset any trips or latched alarms provided that the condition that caused the alarm or trip is no longer present. If there is a lockout time, the blocked start relay will not reset until the lockout time has expired. Starter status. This input must be configured and wired for all motor configurations. The SR-469 determines that a motor has stopped when the phase current falls below the level that the relay can measure, typically 5%, and the starter status input is wired through breaker or contactor auxiliary contacts such that the input is connected to the common when the breaker or contactor is closed. The SR-469 has 3 channels for phase current inputs, each with an isolating transformer. There are no internal ground connections on the current inputs. The phase CT should be chosen such that the full load current is no less than 50% of the rated phase CT primary. Ideally, the phase CT primary rating should be chosen such that the full load amps is 100% of the phase CT primary or slightly less, never more. This will ensure maximum accuracy for the current measurements. The maximum phase CT primary current is 5,000 amps. The SR-469 will measure correctly up to 20 times the phase current nominal rating. Since the conversion range is large, 1 amp or 5 amp CT secondaries must be specified at the time of order, such that the appropriate interposing CT may be installed in the unit. CTs chosen must be capable of driving the SR-469 phase CT burden. Differential current input connections. The 469 has 3 channels for differential current inputs, each with an isolating transformer. There are no internal ground connections on the current inputs. Again, we note that each differential CT circuit is shorted by automatic mechanisms on the 469 case if the unit is withdrawn. The maximum differential CT primary current is 5,000 amps. 3 differential CT connection options are available. The first is the core balanced configuration shown here. This is the most desirable owing to its noise immunity and sensitivity. Summation using dedicated differential CTs. If the core balanced configuration is not possible, the summation configuration using dedicated CTs is the next most favorable configuration for high-speed tripping. In this configuration, it is important to ensure that the CTs and burdens are matched to minimize error. An increase in the delay after a motor start may be required due to the errors between CTs. The summation of 2 CTs per phase into the differential input will provide a larger zone of protection. If the summation of 2 CTs is used, observation of CT polarity is important. Summation with phase CTs. The summation method may also be implemented using the phase CTs as shown. This configuration is the least favorable for high-speed tripping. The CTs and burdens must be matched. The program delay after a motor start may need to be increased from defaults. Both the phase and differential CTs must have the same CT ratio. Ground current input connection options. The 469 has a dual primary isolating transformer for ground CT connection. There are no internal ground connections on the ground current inputs. The ground CT circuits are also shorted by automatic mechanisms on the 469 case if the unit is withdrawn. The 1 or 5 amp input is used for either zero-sequence core balance applications or residual ground connections. The maximum ground CT primary current is 5,000 amp for the 1 or 5 amp input. Alternatively, the 50 to 0.025 ground CT input has been designed for sensitive ground current detection on high-resistance grounded systems using the GE Power Management 50 to 0.025 core balanced CT. The exact placement of a zero-sequence CT so that only ground fault current will be detected is shown here. If the core balanced CT is placed over shielded cable, capacitive coupling of phase current into the cable shield during motor starts may be detected as ground current unless the shield wire is also passed through the CT window. Twisted pair cabling on the zero-sequence CT is recommended. At this time, it is appropriate to review the terms failsafe and non-failsafe. GE Multilin defines a failsafe relay as a relay that is normally energized and de-energized when called upon to operate. It will also de-energize when the 469 control power is lost or when called upon to operate. Within the 469, there is only one failsafe relay, which is R6. It has a Form C contact output configuration and will de-energize if there is a problem with the SR-469. The other 5 relays are non-failsafe, and so they will normally be de-energized and will energize when called upon to operate. Shorting bars in the drawout case ensure that no trip or alarm occurs when the 469 is drawn out except R6, which will de-energize, indicating that the 469 has been drawn out. An LED indicator on the front panel will light when the associated relay is in the operate state. The trip relay, R1, is intended to be used as the main trip relay. It should be wired such that the motor is taken offline when conditions warrant. Depending on the application, the motor may be controlled by a breaker or a contactor. Breaker applications. For a breaker application, the normally open R1 trip contact should be wired in series with the breaker trip coil. Supervision of a breaker trip coil. The SR-469 is able to supervise the trip and close circuits. All that is required is that the supervision circuit be paralleled with the R1 trip and/or close relay output contacts as shown. If connected as shown, the supervision input circuits will place an impedance across the trip relay contacts that will draw a current of 2 mA for an external supply voltage from 30 to 250 VDC through the breaker trip coil. The supervision circuits respond to a loss of this trickle current as a failure condition. Circuit breakers equipped with standard control circuits have a breaker auxiliary contact, permitting the trip coil to be energized only when the breaker is closed. When these contacts are detected to open by the starter status digital input, the trip coil supervision circuit is automatically disabled. This logic ensures that the trip circuit is monitored only when the breaker is closed. If trip coil supervision is enabled and the 52 open-close option is selected for the starter status input, which will be discussed later, the trip coil supervision circuitry will monitor the trip coil circuit for continuity at all times, regardless of breaker state. This requires the installation of a resistor, as shown, to create an alternate path around the 52A contacts in series with the trip coil when the breaker is open. If that continuity is broken, a starter failure alarm will indicate trip coil supervision. The chart shown above gives suggested values for the resistors depending on the control voltage used. Alternatively, if the option 52A close is selected, the trip coil supervision will only monitor continuity when the breaker is closed. Therefore, there would be no need for the additional resistor. For contactor applications, the normally closed R1 trip contact should be wired in series with the contactor coil. Auxiliary relays R2 and R3 are intended to be used for special control functions, such as sending an upstream remote trip command to a breaker on an IOC fault. It is a good idea to decide early on what function each of these relays will perform to avoid assigning conflicting functions to the same output. To ensure conflicts in relay assignment do not occur, several precautions have been taken. All trips default to R1 trip output relay. All alarms default to the R4 alarm relay. Only special control functions are defaulted to the R2 and R3 relays, which can be changed by the user. The alarm relay R4 is intended to be used as the main alarm relay and should be connected to the appropriate annunciator or monitoring device. Block start relay R5 is dedicated to features that are intended to block motor starting. The start block relay should be wired in series with the start push button in either a breaker or contactor configuration to prevent motor starting. When a trip has not been reset on a breaker, the start block relay will prevent a start attempt that would only result in immediate trip. Also, any lockout functions are directed to the start block relay. The fail-safe service relay R6 will operate, in other words, de-energize, if the 469 detects an internal fault or power to the 469 has been removed. This output may be monitored with an annunciator, PLC or DCS. If it is deemed that a motor is more important than a process, the service relay normally closed contact may also be wired in parallel with the trip relay auxiliary on a breaker application, or the normally open contact may be wired in series with the trip relay on a contactor application. This will provide fail-safe operation of the motor, that is, the motor will be tripped offline in the event that the SR-469 is not protecting it. If, however, the process is critical, annunciation of such a failure will allow the operator or the operation computer to either continue or do a sequenced shutdown. Drawout Indicator. The drawout indicator is simply a jumper from E12 to F12 on the SR-469 unit. When the SR-469 is withdrawn from the case, terminals E12 and F12 will be open. This may be useful for differentiating between loss of control power as indicated by the R6 service relay and withdrawal of the unit from its case.